Hello students, welcome to your channel Parivartan Physics. Dear students, in this video we are going to learn how to find the focal length of a given convex mirror using a convex lens. So we are going to use an instrument called as optical bench, which has 4 uprights in this practical. In focal length of convex lens as well as focal length of concave mirror, you have seen only 3 uprights. Here we are going to use 4 uprights. There are 2 pins, 1 lens holder and 1 mirror holder. Right? Okay, so let us begin the practical without any delay. Let us begin the procedure. Okay, so this is the instrument we are going to use, which is called as optical bench. See, here we have a pin number 1. I consider this as a object pin in this practical, right? Okay, after that we have a convex lens here, and then we have a convex mirror, and then we have a second pin that is called as image pin, right? So this is how we are going to use this instrument, right? Okay, next we'll go for the procedure now. Okay, see, now I will explain you the procedure what we are going to do. See, here we have first pin, pin number 1, pin number 2. Here we have the lens, and here we have the convex mirror. For the first step, what you have to do is you should take only the convex lens and remove this convex mirror, right? Okay, so only 3 uprights you have to take at the beginning. Fine. So here I have taken the convex lens, the object pin and the image pin. First thing is, you should find the rough focal length of this convex lens. We know how to find the rough focal length by distant object method that we have seen in focal length of convex lens. The same procedure, using the same procedure, we have to find out the rough focal length of the convex lens. Okay, after getting the rough focal length of the convex lens, keep the object pin at a distance less than or equal to 2f, right? You can exactly keep at 2f. Okay, if you keep the object pin at a 2f, you will find a clear and inverted image of that object pin on this side. So looking at the clear and inverted image of that object pin, adjust the image pin and find out the location of the image. Remove the parallax and you will get the location of the image. After removing the parallax, note down the position of this object pin. I am telling position. You should not take the distance between the lens and the pin here as that of in the practical of focal length of convex lens. There we used to take the object distance, I mean the distance between object pin and the lens, distance between image pin and the lens. Here we should not take the distances, we have to note down the positions. Position means what? Where exactly that image pin is. I mean, since there is a 1 meter long scale on the optical bench, at what division, at which division that object, that image pin is placed, right? So after removing the parallax, note down the position of that image pin, where it is exactly on what division it is. Okay, that is the first thing we have to note down. After noting down the position of the image pin, you should reinsert this convex mirror. Okay, insert the convex mirror here and sit on this side, on the side of object pin, and by adjusting the position of the convex mirror, you have to remove the parallax of object pin with its own image. You will find the inverted image of this object pin from the lens which is coming from the mirror by getting reflected from the mirror. So without changing the position of the object pin, change only the position of the convex mirror. You can, if you want, you can change the horizontal position of this pin. By rotating this knob, you can change the horizontal position, right? So by using the convex mirror again, by changing the position of the, by adjusting the position of the convex mirror, you can remove the parallax of the object pin without disturbing the object pin as well as the lens. After that, you should note down, after removing the parallax, you should note down the position of the convex mirror. Note down the position of convex mirror. So you got 2 positions here, position of image pin, which we obtained only for convex lens, position of convex mirror after removing the parallax, and subtract these 2 distances. I mean these 2 positions you have to subtract. That will give you radius of curvature of the mirror. And divide that radius of curvature by 2, that will give you focal length. This is all about the trial how to take. Okay, this is for the first trial. At 2f you have kept that object pin. I will move that for the second trial. I will move that object pin 2 centimeter towards the lens, and again I will repeat the same thing. For third trial, again I will move 2 centimeter towards the lens and I will repeat the same trial. Right? Finally, we have to find out the mean of the focal length. This is the procedure we are going to follow. I will go for the first trial now. I will show you it step by step. Okay, the very first step is we have to find the rough focal length of the given convex lens. See, here is the convex lens and here I have taken a screen. You can see I have focused a distant object. I mean, there is a window and I am focusing the image of that window. So now the image of the window is blurred, right? So as I move it away from the lens, you can find it is getting cleared, right? So at certain position, what happens? The image of the window will get clear. When you get the clear image of the window, at that time stop moving that screen and you have to note down the distance between lens and the screen. That will give you rough focal length, right? Okay, now let us see how much is the rough focal length. I mean the distance between the lens as well as the screen. Okay, you can observe here the lens is at 65th division. Lens is at 65th division and the screen is at it is at 48th division, right? 48. So this is 65, that is 48. It means the distance is 17. So rough focal length is 17 centimeter. Okay, see, we have found the rough focal length of the lens. It is 17. So 2 times of f will be 34. And the object pin has to be kept in between f and 2f actually. So it has to be close to 2f, right? Keep the object pin at a distance less than 2f. You will get the right readings. Okay, now just check the position of the lens. You can see the lens is kept at a distance of how much? Sorry, at which division it has been kept? You can check there. It is at 65, right? The division number is 65. Okay, 65. And where I have kept the object pin, see, this is 65, this is 75, this is 85, and this is 95. So the lens is at 65th division and the object pin is at 95th division. It means I have kept the object at a distance of 30 centimeter. What is 2f? 2f is 34. I have kept it as 30 centimeter, right? So less than 2f I have kept it. Okay, keeping the object pin at a distance of 30 centimeter. Now I will remove the parallax of this object pin looking at the opposite side, sitting at the opposite side of the object pin. Okay, let us see how to remove. So here is the image pin now. So sitting on this side of the optical bench, we have to remove the parallax looking at the inverted image of the object pin, right? So now let us remove the parallax of that object pin. I will just show you how to remove the parallax right now, right? Okay, we'll go. Okay, now you can see there is the object pin, right? And middle we have lens and here we have the image pin. So we're sitting on this side and you can observe there is a inverted image in the lens. Hold your eye in such a way that the tip of the inverted image is visible at the center of the lens. I will show you it a little bit clear. Okay, now you can see the clear inverted image of the object pin in the lens. Hold your eye in this position only so that the tip of the inverted image is visible at the center of the lens as you are looking now, right? As you are seeing now. See, now what we have to do is, this is the image pin and there we have the object, inverted image of the object pin. Now we have to make the tip of this image pin coincide with the tip of that inverted image. So for that we have to remove the parallax, as well as for this we have these many adjustments here. You can move this needle front as well as back and you can adjust the height by rotating this knob. You can adjust the height of this pin, right? So now let us see how to make them coincide at the center. See, you can observe that the inverted image is visible. Now what I will do is I will raise the height of this pin. Okay, I will raise the height of this pin, take them to the same horizontal level. You can find there is a horizontal gap in between them. So by rotating the knob, we can move it horizontally. See, you can rotate the knob which is present at the base of that pin, which makes you the tips to coincide with each other. You can see they are moving far apart. So I will rotate it and I will make them to coincide at the center. So there is a slight gap again. So we'll again move it. So the tips will get coincided at the center. Still there is a slight gap. Okay. Now you can observe the tips are getting coincided, right? I am moving the base knob of the object pin. So like that, the tips has to be coincided. See, you will have the knob here also. You can see here also you will be having the knob. For this also you have a knob here actually. For this base I'm not having, but that type of stand you can take, right? So that you can make the adjustment here. Okay, now you can check the tips are getting coincided at the center of the lens. Clear? So here you can see the tips are getting coincided at the center of the lens. Now if you see, if you move your eye to the right or left, you can see the tips will get separated, right? So I'm moving my eye to the right side, the tips are moving to the left side, they are getting separated. So there is a horizontal gap in between them. So for this, what you have to do, you should move this pin towards the lens. You can observe the tips are getting closer. If the tips are getting closer, you move it forward only, further only. Otherwise, you have to move it backwards. Okay. So the tips are getting coincided now. Yes. So now the tips are said to be getting coincided. The tips are overlapping. That's why I'm adjusting the height. Okay. So the tips are getting coincided now. You can check at the edge of the lens, they are coincided. They are not getting separated. Now check again at the center. At the center, again they are coinciding, right? At the another edge, there is a slight horizontal gap. So I will move it either forward or backward so that the tips will get coincided. Okay, now the tips have got coincided at the edge. At the center, there is a slight horizontal gap. For the center horizontal gap, you use the knob and you can find the tips getting coincided, right? Okay, so now the tips have got coincided at the center also. You move your eye to the right side, the tips are getting coincided and moving to the left side. Again check at the center and check at another edge. So like this they have to move, right? So there is a slight gap, let us fill it up. Okay, again there is a slight gap, so minor adjustments you have to do and you have to check. Okay, yes, now the tips are getting coincided and then they are moving. So this is how we have to remove the parallax. Now the parallax has been removed and you can note down the position of this image pin, position of the image pin, where it is on the scale, that we will check and see. Now we have removed the parallax using convex lens only. So this is convex lens, that is the object pin. So only by using the convex lens we have removed the parallax. Let us check what is the position of the image pin. So this is the image pin. Image pin is present at, this is 25, this is 26, right? So it is at 26th division, right? So note down this position of the image pin. Okay, see, we have removed the parallax by using the convex lens and we have noted down the position of the image pin. Image pin is at 26th division. After this, without disturbing the object pin as well as the convex lens, insert the convex mirror in between the convex lens as well as the image pin. So here I will insert this mirror, right? Okay. After inserting the mirror in between these two, what we have to do? What is the next step? Don't disturb the object pin as well as the convex lens. Sit on this side. See, first image we sat on this side and we had removed the parallax and we had taken the position of the image pin. Now interchange, come on the opposite side, come on the object pin side, sit there and you can observe the inverted image of this object pin which is getting reflected from this mirror through the lens, right? So the inverted image of that will be visible when you sit on this side and you observe it. Now what we have to do is, as you are observing the inverted image of this object pin, you have to remove the parallax of that inverted image by adjusting only the convex mirror. You should neither move the object pin nor the convex lens, only move the convex mirror. So by moving the convex mirror, you have to remove the parallax, and after removing the parallax, note down the position of the convex mirror. That is the position of convex mirror. After getting the position of convex mirror, you have already got the position of the image, right? Subtract these both positions, you will get the radius of curvature of the mirror. After getting the radius of curvature, you have to divide it by 2, you will get the focal length, right? This is the first trial. For the second trial, what you have to do, you should move this object pin by 2 cm towards the lens. Move that object pin 2 cm towards the lens. Again, remove the convex mirror. remove the parallax for the image pin. You will find the position of the image and again reinsert the convex lens. Again sit on this side, remove the parallax for the inverted image of the object pin and note down the position of the image. The same thing you have to repeat. Same thing you have to repeat. So at least you take 3 trials for this, right? So by moving 2 centimeter and 2 centimeter, you can take the next trial, right? So that is what we are going to do. Let us move on to the further procedure, further step. Okay, now we have inserted the convex mirror, convex lens. You can observe here. See, there is the image pin for the first image location we have got. Next to that, we have the convex mirror. This is the convex lens, and here we have the object pin. This is the object pin, right? So here we are sitting and we are observing. We can see the inverted image there in the lens, which is there in the mirror, which is coming through the lens, right? So very first thing is again the same steps we have to follow what we have done while removing the parallax of only convex lens, right? So first you hold your eye in such a way that the tip of the inverted image is at the center of the lens. Next, what you have to do, you should coincide the tip of this object pin which is in front of your eye with respect to the tip of the inverted image. Make them coincide at the center first. Okay, we'll see how to do that. See, there are totally 3 adjustments in removing this parallax. First thing is you can rise the height or you can reduce the height of this object pin. First thing. Second thing is you can move this front and back. You can move this front and back. And third thing is if there is a horizontal gap in between the tips, you can rotate this knob to clear that horizontal gap, right? So these are the adjustments we are going to do. Okay, now let us see how to coincide the tips at the center of the. Okay, now you can see the inverted image from the mirror which is coming through the lens, right? So you should hold your eye in such a way that the inverted image, the tip of the inverted image is visible at the center of the lens. Okay, so you can check there is a vertical gap in between the tip as well as the tip of the inverted image as well as the tip of the object pin, right? So first you reduce this distance, vertical distance. For that, what we have to do? For that, we have to rise the height of this pin. So I will slowly rise the height of that pin, okay, so that the tips will get coincided at the center. Okay, you can check there. The tips are getting coincided at the center. So like this, the tips should get coincided at the center. Now, you move your eye to the right side as well as left side. You can observe there is the parallax. Okay, if I move my eye to the left side, the tips are moving to the right side. Okay, check whether the tips are getting coincided and they are moving or they are not getting coincided. Okay, so you can just check here. Okay, let me check it at the center again. I will focus it first. Okay, let me focus it, right? Okay, so if I move my eye to the right side, the tips will move to the left side. Okay, so they are coinciding and then they are only moving. So it means that the lens is exactly, the mirror is exactly at the correct position, right? So there is no parallax now. If there was a parallax, you have to move the position of the, you have to change the position of the mirror, right? So I will just show you. So if I change the position of the mirror, the parallax will get formed. Now it is actually the parallax has been removed. You can directly take the position of the mirror. But if I change the position, if I change the position of the mirror, you can find the parallax over there. Now I have changed the position. Actually, there is no necessity of changing the position. See, now there is a parallax, right? Now there is the parallax. So to remove this parallax, what we have to do is we should not change the position of the object pin as well as the lens. You have to change the position of the mirror. So let us change the position of the mirror. We have to move the mirror backwards slowly, until the tips get coincided. Okay, you can see that the tips are coming close. The tips are coming close. Yes, yes. Okay. So you can observe the tips have got coincided now, right? So like this, if you move the mirror, the tips will get coincided. You can check the tips are getting coincided, right? So here you can check the tips are coinciding at the center also and they are coinciding at the edges also. Like this, the tips should get coincided. Then we can say the parallax has been removed. Okay, after removing the parallax like this clearly, we have to note down the position of the mirror now. Okay, let us note down the position of the. So we have removed the parallax now by using both convex mirror as well as convex lens. This is convex lens and this is convex mirror, right? So now we have to note down the position of this convex mirror. So where is the convex mirror? As we have already seen, the lens is at 65. So the convex mirror. So where is the convex mirror? The convex mirror is exactly at 55th division. You can check there. It is at 55th division. So the position of convex mirror is 55th division, and the position of image pin, this we have already noted down. This is at 26. So these two positions we have to note down. After noting down the positions of these two, we have to calculate the radius of curvature as well as focal length. That I will show you in the calculation. Okay, the position is 55. Okay, so we have taken the readings now. See what we have done. First, we took only convex lens without convex mirror. This is the object pin. We have removed the parallax and we had noted down the location of the image. So that location of image we have noted down here. Position of the image. Position of image I is nothing but it is the position of the image which has been formed only by using convex lens without convex mirror. After finding the position of this image, we kept the convex mirror in between the lens as well as the first image. Right? In between the first image as well as the lens, we kept the convex mirror. Sitting on the side of object pin, we again saw the inverted image of that object pin and we removed the parallax by adjusting the convex mirror. So after adjusting the convex mirror and removing the parallax, we had noted down the location of the mirror and that position of the mirror is noted down here. So for the first trial, we have seen already in the video, the first image we got at 26 and the mirror was at 55, right? So the radius of curvature of the mirror is 29 and focal length is 14.5 centimeter we have got. For next trial, what you have to do, for the second trial, you have to move this object pin by 2 centimeter towards the lens, right? So if I move this towards the lens by 2 centimeter, again I have to remove the mirror and I have to take the location of the first image, and then insert the mirror, again sitting on the object pin side, remove the parallax and note down the position of the mirror. You will get this much readings. So I repeated the same thing by moving 2 centimeter towards the lens. For each trial I have taken 3 trials here. So I have got the mean focal length as 15.85 centimeter of that convex mirror. So this is how we have to find the focal length of the convex mirror by using convex lens. Dear students, if you find the video useful, if you find the content of this channel useful for you, and if you like the content of this channel, please don't forget to subscribe the channel and please share the video, share the channel with your friends. Please refer the channel to your friends as well as juniors. Right? Thank you so much for watching and supporting this channel. Please keep watching and supporting this channel. If you need anything else, please put a comment in the comment box. Thank you so much. We'll meet again in the next video. Thank you.